morning, dear students. Today we are going to start our section with the topic Cori cycle. This Cori cycle is very important for your exam, so don't skip this one. Again, we can understand what is Cori cycle while we are doing some vigorous exercise. It is simple logic that our muscle need more amount of ATP than in normal resting condition. So that time for generating more amount of ATP, the muscle depends anaerobic glycolysis also. And as the muscle start to depend on anaerobic glycolysis also to supplement additional amount of ATP, it will result in the accumulation of lactate. And this accumulation of this lactate cause fatigue. Okay. And this accumulated lactate, it diffuse into the blood capillaries that is supplying the entire muscle. And this lactate through the blood, it will reach the liver. And on reaching the liver, that lactate undergoes oxidation to produce pyruvate, and then this pyruvate it enters the gluconeogenic pathway, that is glucose synthesizing pathway from non-carbohydrate sources, and results in the formation of glucose. And this formed glucose is again passed through the blood and will reach the muscle. Then that glucose can further undergoes metabolism to liberate ATP for the further supply, further energy supply for the muscle to do the vigorous exercise. And this Cori cycle is also known as glucose lactate cycle. What is it? Glucose lactate cycle. Next, we can understand about simple muscle twitch. What is simple muscle twitch? That means upon receiving one simple stimulus, that muscle undergoes a contraction, and when that stimulus or action potential disappears, then the muscle is relaxing. That single contraction relaxation cycle is called a simple muscle twitch. So that is what I expressed here. Simple action potential on in response to that simple action potential, a brief contraction is happening, and after that a relaxation. So that is simple muscle twitch. Then how can we record that simple muscle twitch? Which is the apparatus for doing that? Its name is kymograph, and its image is shown here. In this picture, we can see a stand, a board, and a stand, and this stand is having a needle, and that needle is touching a drum, and that is the setup. And the muscle that we are taking to record the muscle twitch can place here. Its origin portion we can firmly fix on this board, and the insertion point of that muscle we can connect with this needle. And on giving an electrical stimulus, the muscle will twitch, and in response to that twitch, this needle will move and will mark that movement over this drum. So that is the process. So let's see how we can record the muscle twitch using the kymograph. So we can say that this is the muscle that is mounted. Here it is not mounted on that board, instead to the stand itself. Anyway, we can see clearly the movement of that needle, and the way how it marks that the muscle twitch. Okay, then we need to understand about the muscle twitch curve. So this is the muscle twitch curve. This is also an important question, and if such question came, then you need to answer like that. You need to draw this picture, and also you need to mention that graph contain three periods: latent period, contraction period, and relaxation period. By the name itself, to some extent we know what exactly happening in each period. During latent period means it is the initial stage just to begin a contraction. And during that period, actually, we have learned that calcium that is stored in the sarcoplasmic reticulum is releasing out and it is availing to the troponin. So that process is happening during this latent period and its duration is 10 milliseconds most probably. After that, the contraction is happening, muscle contracts, and that period lasts for 40 milliseconds. And after that contraction, then the relaxation period, it is the longest period in that muscle twitch, and its duration is 50 milliseconds. The total duration of muscle twitch can sum up to 100 milliseconds. This is the general concept. But that duration varies while coming to different vertebrates. In the case of mammals, it requires only 10 milliseconds. Okay. Next is about the refractory period. Refractory period means what? Refractory or the resting period. After a single contraction relaxation cycle, the muscle will take a short while of rest, inert phase. It will not undergo any sort of contraction during that period, and that period is called the refractory period. So, a refractory period is the brief period in that muscle contraction relaxation cycle, and during that period, muscle will not respond to a second stimuli. So, that is refractory period. Next, we are going to understand about summation of contraction. Summation of contraction means summing up of contraction. How summing up will happen? Let's see. So look to this image. On looking to this image, it will become clear to you. This is the graphical representation of simple muscle twitch or simple muscle contraction. Here we can see one action potential. And in response to that, one contraction and relaxation is happening. And look, the second case. Here, two stimulus or two action potential is supplied to the muscle. And when it is supplied, that's important. That time should be either during the contraction or relaxation phase of that muscle. Then what will happen? A second contraction will occur, and that second contraction will superimpose over the first contraction and will result a bigger contraction having high tension compared to that of a normal muscle twitch. So that is summation, summing up. I think the idea is clear to you. So look here. A second stimulus is giving either during the contraction or relaxation time of the muscle, and that will result a second contraction superimposed over the other. So that is what summation of contraction. And also one more thing we need to understand, that the application of the second stimulus is during that one contraction relaxation phase itself. It is not giving after the muscle complete the relaxation. If it is give after the completion of relaxation phase, we know that is a refractory period. That time muscle will not respond. Instead here, that second stimulus is giving during the contraction or in the relaxation phase of that muscle itself. That is why a second contraction occurs here and it gets superimposed over the first and resulted a greater contraction. Okay. Next, we can just understand about tetany. Tetany means it is a hyper-contracted condition of the muscle. Highly contracted condition of the muscle as a result of repetitive muscle stimulation that we can see here. These two are two conditions of tetanus. I will explain to you later. First, look to this image. It is a hyper-contracted. Compare this figure with this one. This one is the summation. Here we can see only two stimulus application. But as we look here, we can see more than two. So many stimulus are applying during that contraction or relaxation phase of that muscle. And that results that that muscle is sustaining. It is persisting in the phase of contraction itself for long. So that is the condition of tetany. Hypercontracted condition as a result of repetitive muscle stimulation. It is a sustained contraction. And in that situation, the muscle is not getting enough time to completely relax. And the individual responses fuses to give a continuous contraction. So that is tetany. What would be the reason for this tetany? Maybe the depletion of ATP. We have learned that the molecular mechanism of muscle contraction video, we have learned that ATP is necessary for the myosin head to detach from that actin filament. So as the ATP level is depleted, the muscle cannot undergo relaxation phase. It cannot relax. So that might be a reason for this tetany. Okay. Then we need to understand two situations, complete tetanus and incomplete tetanus. So this is incomplete tetanus and this is complete tetanus. Let's see what is the difference between these two situations. Here we can see a little relaxation. The muscle is getting a little time to do some relaxation. So that type of tetanus is called incomplete tetanus. Okay. Here some degree of relaxation is allowed between stimulations because that frequency is low when compared to the frequencies that we can see in this case. The interval period between this action potential is less. Here the interval period is high. So that is why the muscle is getting a little time to undergo relaxation. So that is incomplete tetanus. Then coming to complete tetanus, I think it's already clear to you. There is no time, no time is giving to the muscle to undergo any more relaxation. The result is a fused contraction, a sustained contraction that is called complete tetanus. Okay, I think it's very clear to you. With this, we can wind up today's section. Thank you.
I'm an icon, man. Ain't my girl about a 10. I should fuck her in the Benz.